Now let us go into the code and write a code for this particular function. As we will write the code, we will think of the base case and we will solve it based on the framework and also draw the recursion tree for the same. So let me define a function def first index of an element. Let's say we will be giving a list L1 and let's say X, I'm taking the number which will be there. So let me just write pass as of now. And let me just call this particular method. So I'm taking the same example 3, 2, 5, 2, 8, 2, 1. And let's say we want to find for 2. In a very similar way, we will be just finding for, I would say, other cases as well, but that should be easily doable. Let's say 10 and let's say 1. Okay. Great everyone. So now let's solve this particular question. Let us first think of a base case. So as of now we have seen that we are actually following a very good, I would say, framework. The very first step in this particular framework is base case, right? In base case, as we have already seen in lists and array, we normally take when the size is 0 or 1 because that is like the minimum size or minimum, I would say, array which we can get, right? So if your length of L1 I feel is 0, then we can very comfortably say that we are not going to find this, right? Because in a 0th element, how can you find any, in a 0 size array or list, how can you find any element? So we can return -1 safely. Now, of course, I have made it clear that if it is not found, I have to return -1. If the question requires anything else, based on that, you should return that particular value. Now let us focus on the next part, which is how should we go about this first index of our element first, right? We see already in the last question which we did that we can either do the step or I would say our work first or make the recursion call first, but that is also depending on lots of things. For example, in a print 1 to n and n to 1 function, we saw that how calling the function first was helpful if we want to print 1 first, right? Because so that everything will cripple down towards 1 and then it will be printed first, and then while the function's calls are returning, we will print n in the last. While the vice versa, basically where we were printing n first, that was true in printing n to 1 use case, right? So if you have not seen that video, please make sure that you see the same. Now in this particular question as well, I personally believe that if we are checking first only, if we are able to check first before making the recursive call, that will be helpful instead of making the full recursive call and then actually seeing that okay, if we are able to find the element or not, right? Because provided that I have to give the first element, I have to tell the first index, what if it's actually the very first element? So if you are working on the first element and asking recursion to work on the leftover part, then please make sure that you are actually finding the same thing first, right? So I will just quickly write the same thing so that you have these things in notes as well. So for first index, we have our base case, right? Second part, what we can do is if L1 of 0, okay, if L1 of 0, we have, let's say, equal to x, then we can return this particular index, or we can return 0. We will see what exactly that's going to do, and then we can make a recursive call. So now let us code this and see what exactly is going to happen. Let me just for the time being remove this thing, and yeah, cool. So pay attention everyone. If my L1 of 0 is equals to x, now the thing is, what should I return? Thinking that okay, if I'm able to find it on the very first element only, let's return 0 for the time being. And let me now call recursion because I believe that it is going to give me the answer. So let me call recursion on the leftover part, right? So x is going to be same while I'm going to return the recursion part for this particular thing. So let us first check it for 3 and try to run it. Seems to run. 3 basically is coming the very first time on the 0th index. That seems to run. This particular code seems to run for the element of 3. But is this code then correct? Let us check. Let us run it for 10. If I'm running for 10, it is returning -1. So this also seems to be right. But now let us see. And this is also something which I want to make sure that you understand. That is why I'm doing this question in front of you. That please make sure that you are running your solution on multiple use cases. Your solution should not just, I would say, pass the use case on which you are thinking, okay, but other use cases as well, or other test cases as well rather. Okay, so while development, of course, we talk about in terms of use cases, but while you are solving these questions, please make sure that you are running it on different test cases and not just on a single. You can write your code and the logic based on a single test case which you have in mind, but please make sure that you are testing on each and every of these edge cases, I would say different scenarios and everything. Okay, so now let us test it for 2, and I'm seem to get 0 now, and I feel that's wrong answer. I should be getting 1 as an answer, right? So we saw that how our solution was working fine for 2 of these test cases, but it failed here, right? So now let us deep dive and see exactly what would be the problem. Let me first explain you here only, and then we will see the same. So what would have happened is that when I would have called my particular function, this particular function, then I would have sent this 3, 2, 5, 2, 8, 2, 1, and I would have sent 2. Now, first we would have checked base case, that is of course not true. Then would have checked for this particular use case if L1 of 0 is equals to x, and then we would have made a call, right? Now when I made this call, I would have sent 2, 5, 2, 8, 2, 1 and 2 again. Now in this particular use case, in this particular I would say call, what would have happened is that L1 is now this particular array or list, right? L1 of 0 is coming out to be 2. And we say that, okay, we are returning 0. But one thing which we have missed here is, one very important thing which we have missed here is, for this array, this is the indexing, this array or list, but here this is the indexing. So when I am actually slicing my list and sending it into the next function, then each and every of this element is actually getting its index -1, right? So when you see this 2, it is having 0 index, but in the original array it was having index as 1. So when the slicing happens, of course, the index of your elements also changes. In the next step, it's going to move one step behind again. So 5 actually, this particular 5, sorry for this color, yeah, 1 second. So 5 is actually going to be coming on your 0th index. This is going to come on your 0th index, right? So that means that though we are right, this particular function is right when it is returning answer as 0. The same index is actually not true with respect to our main function or with respect to the array which we sent at our end, right? So that means that we will have to handle this use case as well. So let us see this once again. Let me show you this a little bit more nicely so that your understanding is clear. So pay attention everyone, what I exactly want to tell. See. When I'm calling the first index of a number, of course the function gets created and I'm calling it. So this is the full list as of now, and this is the indexes. Pay a lot of focus on this particular indexes. Okay. Now when I make the next call, let us make it for the base call. So this is what I was saying. When I make the next call, if you will see, if you're gonna see, this is how we are shifting our particular elements in our list, right? So the index is actually reducing by 1. So for this particular function, whatever is at index 0, it is at index 1 for this particular function, right? So that means that whatever answer we are getting from here, we cannot directly return that. We cannot directly return that because that's a problem. That's again a problem. We have not written our function, or we have not done our work properly. Because if you will see, in our work, we have missed out the use case if, let's say, what if we are in any intermediate function or something, right? So when it is getting returned, that's giving us a problem. So let us solve this, everyone. Let us try to solve this. The simple solution for this, can actually be that whatever index we are getting, let us add 1 to it, right? So for example, if we have some function like this, so whatever is 0 here, whatever is having a 0 index here, it will be 1 here, then it will be 2 here. Similarly, it will be 3 for this particular function, and that would be the final answer, right? So let us try this once and see if it is able to solve our answer, I would say problem or not. So what I'm saying is return whatever I'm getting from below plus 1, and let me run it now, and this seems to work now. So I'm able to get my answer. Okay, let us run for 3 as well. 3 I'm getting 0, but now let me run for 10. and 10 I see that I'm getting 0. Oh sorry, I'm getting 6. Now what was the mistake here? We have to actually check one more thing. What if the element is not found? What if the element is not found and -1 is getting returned? Then don't you think that it's a problem? Because we are, even if the element is not found, even if the answer is -1, we are still adding 1 and returning the answer upwards. And that's a very big problem, right? So what's going to happen there? I can just quickly show you that. We get x 10. So for the purpose, I'm just reducing this array to, let's say, this length so that it is easier to visualize. Okay, we will be able to see all the functions as well. Pay attention, everyone. So we are going to make the call. We know that we are not going to find it, right? So let us go to the very last, I would say, call. Now pay attention. If it would have been 2, okay, then yes, it is 0 here and it is 3 here. We would have added the 3 in these 3 functions. We would have added +1, and of course we would have gotten our answer, right? But here there is a problem, right? It is 10. Now when we see for 10, the base case is gonna get hit. We are gonna return -1, and without even checking, we are returning everything, right? So see, this value which should have retained -1, this is gonna again get added by 1, and we are returning the same thing. So that is again a problem, right? That is the reason we are getting 3 here. So that is a very, very big problem. The fix is very simple. See, the understanding is to find these small problems, and that is why I'm making sure that I'm moving incrementally in front of you so that you also understand this function. Now solving this is of course very easy. If, what I would say is, if my function, or let me just get answer from recursion, it is like this. What I have to check is, if answer from recursion, if it is -1, then I have to just return it as it is. But if it is not the case, else I will just return whatever answer I'm getting from recursion +1. Now this will actually handle all the cases. This is going to handle all the cases, and we can see the same as well, right? So pay attention, everyone. See, so let us save, yeah. See, 1, -1 and 0. So 2 is coming at 1, 10 is not there, so -1, and first is coming at, okay, let us see, it is, oh sorry, 6, yeah. So that works fine, right? I write it at 0, but yeah, it is coming at 6. So I think that works for all the use cases. Again, I have shown you all the small mistakes which you can do in these types of questions. Please make sure that you are actually checking your answers and dry running your code. So you are making all these things which I am showing you by drawing on the screen, as well as through Python Tutor. Just one advice, don't directly jump to Python Tutor. Please first make sure that you are able to draw on your notebook or somewhere first and get the answer or get the mistakes at your end first. Okay, because that is something which will help you to solve the question in any interview, or I would say any particular platform whenever you are attempting them. So with that, I hope the first index is clear. The recursion tree I kind of already showed in front of you, which you can make as well. So recursion relation is also pretty easy. So I hope this question is clear. Now I would like you to test out this last index of an element. Of course, that is very easy as well. So I will just give you the, in this particular notebook only, I will just change this thing, and you have to write this function. Okay, so you have to write this function now. I believe that this will be pretty easy to do. All the things remain the same. If you have understood first index of an element properly, then last index of an element should be a lot easy to write. If you take care of all the things which I have actually told you while solving the thing. So I expect that you will be solving this thing on your own, and I will be providing you with the solution. Please make sure that you are covering all the use cases, all the test cases, and also make sure that you are drawing the recursion tree when you are writing the solution. Okay. So thanks a lot, everyone. With that, we are actually very close to covering all the concepts in recursion and arrays as well. In the next few videos, I'm going to solve a little bit variation of this particular problem, and I will be teaching you, I would say, many things which we have to take care when we solve these, I would say, array and list and recursion kind of a problem, which will help you to be a better coder or write better code in and all. Okay. So please make sure that you solve this for last index of an element. It should be pretty, I would say, simple to write now, because I have already discussed in depth about first index. Just make sure that you're following all the steps as it is. Okay. So thank you, everyone. Let's meet in the next video.